So my name is Michael Lopez, and this is the capstone final. And they go around the dial, and it sorts them for their various properties. So everything's ready. You can press start, and it starts moving. So right now, the pusher, when it senses there's a part in the hopper, it pushes it, and if there's no part on the dial, then it pushes it. Then it goes to the metal detecting sensor, then the height laser sensor, and then right now the first part is being buffed. It'll move on. It moves into an empty stage right there. And basically when the camera's done, it either gives it a pass or a fail. And when if it passes, it'll go to station 7, and then the robot will pick it up, take it off, and put it on that scale, and it'll weigh it, flash the weight into the whip, pick it back up, put it back on station 7, and then rotate the dial again. And once it makes it to station 8, it'll pick it up and then sort it into the 5 spots there: tall plastic, short plastic, tall metal, short metal, and a reject spot.
Describe what all you had to do for this project.
So all the hardware was here, and all I did was program the PLC, which is in here. I had to program this HMI screen, make it look nice and pretty. I had to program the sequence for the part buffer to see the robot starts going. I had to program the Epson, and then I had to mush it all together and make sure that everything talked to each other, and everything makes sure that everything knows where it is, and that'll just do its job. So right now it's going to weigh that tall metal part because it passed everything else, and if it didn't pass, if it rejected at one point in the process, it will just skip that and then move it to the reject.
So how do all the pieces communicate?
So there's the parts of the machines. So everything is tied together through the PLC. And the PLC has different drivers for the Epson, for the Cognex, and then it has its own discrete I/O bay and analog I/O bays. And yeah, the PLC does all the heavy moving. It commands the robot to move to its position. It commands the sequence for the buffer. It tells the camera when to take the picture, and the camera tells the PLC if the picture was good or bad, and then it decides to move that to wherever it needs to be, such as that tall plastic one there. And then it also tells the dial to move after it gets confirmation that everything else is safe, so the dial can move.
How does it do that communication? What does it use to communicate to the robot and to the camera?
For the robot and the camera, they all are connected by an Ethernet driver for their separate machines. And it's pretty simple to set up. You just have to make sure the model and the manufacturers programmed it correctly, and then you can move that into the PLC programming code, and then it's a lot easier to handle the inputs and outputs. For, say, like the Epson, it has its own Ethernet card and of inputs and outputs, and that just tells the PLC where it's at, what it's doing, and what it needs to be commanded to do.
What did you do for your data logging?
Data logging, I had 2 systems that I set up, sort of. One kind of works better than the other. But so I can log things from the HMI program that'll give me a data log of the last what parts had been counted every 30 seconds. And that logs it internally to the HMI, so I can put a USB back there and collect the data from the HMI. And then I have 20 parts that are logs to the PLC itself. So those can be pulled up in part data. So right now I have a little animation of what's there and what's not. I have a list of parts that have gone through, and then I have 2 data pages of the last 20 parts that were run through the system. And then so this part right now, once it reaches station 8, it'll put itself into part 1. And so right now that was passed. It passed the camera. It's metal, short, and it's polished. A height of 750 thou, and a weight of 38 grams. And the last part, it just falls off the edge of the universe. I mean, I could have made that longer. I could have done like 100 parts or something, but it only called for 20. And the rest of the data, which is more extensive, is actually logged into the HMI itself. I think it has about 1,000 data points it'll log before it starts cutting off.
What was the hardest part for you?
Oh, see, I'm not very good at programming Epsons, and I'm not very good at programming HMIs. So those are kind of a tie for each other. The Epson, I was having a lot of problems because when I took the Epson class, I didn't like doing the Epson, so I didn't pay too much attention. So I had to relearn a lot of the Epson, and that was very annoying. And the Epson is very touchy, and compared to the Yamaha, it is very slow. I like the Yamahas in there, the Yamaha Scares. They're much faster. And I had a lot of trouble with the syntax because I forgot a lot of it since I last did the class. And then for the HMI, the actual design of the HMI is not too bad. I had a lot of fun in the HMI class, you know, just like mapping all my I's and O's and getting all the buttons to work and everything. But the problem is with the actual HMI programming system is that the programming software, it likes to time out every 30 minutes. So if you're doing something else and you come back and you don't save your thing, it'll lose a lot of your progress. And it's very touchy when you're trying to go and setting up the runtime security. So you can get into stuff like user logging, user logout. When you go into those settings in the program, it's very buggy, and it'll seize and it refuses to do anything else until you restart your entire computer, which is very, very annoying. So technically it's the Epson, but in actual movement it's the HMI.
Walking in right off the street without knowing anything, this looks to me like a quality control
Inspection, yeah.
inspection, right? In layman's terms, would you be able to sell it to me, tell me what I would need this for, what applications they would be good for, and how it could improve, like, if I was running some sort of manufacturer, what industries would this be applicable to?
So to a layman,
Yeah, just as a man who has no idea all the acronyms of the set.
so for a layman, it's very difficult because a lot of these in real life are custom built to certain applications. So for example, I think at Pepperidge they have their own, They have their own goldfish line, and every part of that goldfish line is catered to each specific part of making goldfish at that point. And so to a layman, it's very difficult to sell unless the layman has, you know, a very complicated system. It's not like you can go to a dealership and just pick one of these up. Like, they have to be, the hardest part is integration, and that's basically all this is. I had to make the robot talk to everything else and the PLC to everything else. And it's all of this system is customized around sorting these little bits. So basically, wholesale, not really, but if you're talking to like a plant manager, it's very, very sellable at a very custom viewpoint.
Okay, so if he was making little cylinders, what
Yeah,
would
if I'm the owner of
this
the
do for
company,
him?
like,
What advantage
why
would
should
it
I
have?
spend money on this?
Yeah.
The advantage is that it is one operator. All of it is controlled from a very user-friendly screen right here. And it's very secure. You have a security bit with logins, and you can add users, take away user privileges. And you can log lots of data, which is, I did 1,000 points because that's just the default setting, but you can probably log 10,000 points. You can log as many parts as you want, basically. Very user-friendly. You don't have to know too much about the PLC part. The PLC is basically bulletproof. And very minimal training requirements for the operator, who doesn't really have to be trained at all. It's probably take like an hour to get used to this thing. And now it's running out its parts, and it's in a pause position. So if the hopper was taller that I could put parts in there, I could just put parts in there and just hit start again, and it would do its thing.
Tell us about what kind of voltages do we have going on in this machine?
That's kidding. Okay, so it's a 120 inline. It just comes off the same line that my computer uses. And but the voltage is stepped up throughout the system, so I'm not sure about the servo. I remember it not being 120 volts. I'm pretty sure it's at least 220. I think so. And then the robot uses, I think, a standard 220. I think, but I'm not exactly sure on that. But the industry standards is like 240 all around. So everything else, the inputs, outputs, all the discretes, they're all I think 24 volts from the PLC, so that's a 24 volts is a pretty standard signal for the PLC's discrete ins and outs. And then the scale, I think, is an analog input, and I think that's a 4 to 20 milliamps scale, so it uses 24 volts in and then measures the output amperage to get the weight. And then, not sure about the motor. I think it's 120 because it's small enough, but
Where would you go to find out if you weren't for sure?
there's a sticker on the back. It probably says right there. It's just like I'm too far away to read it. And then there's a sticker on the back of there.
Where else?
User manuals, that's about it.
About the schematic.
You can read the schematic too. I didn't have any schematics for this thing, and there was a few, but they were just kind of, they were all pertaining to the wiring in there. So if I had read the schematic, yeah, you could pull it up from there. But I just kind of went in blind. I just had to make sure it was okay.
What's the weak point of the machine?
Probably, there's a few weak points, and if I had designed this, I would have switched the buffer and the camera, because there are some, like there's a steel part that goes in there every once in a while. So there's one that has a chamfered edge, one that doesn't have a chamfered edge. And when it gets the chamfered edge on the bottom like that, it has a tendency to get hung up on the dial circles. So it'll yank the dial just a little bit and put everything out of whack. Like one time I accidentally crashed it in one of those bits with the buffer wheel, and it yanked the dial like this. So it was failing all of my height measurements because the dial was moving like this after it crashed. And if the camera had picked up that it hadn't been chamfered yet, it would have just skipped that part and moved on. And so probably the weakest physical point is probably the dial, mainly because it's plastic. If that was steel, it would probably do a lot better measuring wise. But operationally, the Epson is very, very touchy. It takes getting used to from a programming standpoint, and when you actually get to use it from the HMI, it's even more obscure. So that's probably the weakest spot, because it doesn't like telling you what it's doing. It just does. The camera is actually very nice. I thought the camera would have been terrible, but the camera is very reliable. It as long as it's programmed correctly, it's very reliable. I've had a lot of fun with the camera, and everything else is, you know, pneumatic, digital, on and off, very, very basic, low level. Just it works, whatever.
What softwares are used for what? Like,
all right, so the Epson has its own proprietary software. You can actually do most of the coding as I did in WordPad, but to actually record points for the actual robot, you go into the Epson programming software. The Cognex, have you done the Cognex? This is over there. Yeah. Oh, yeah. So this one uses a different Cognex software, but it's the same Cognex software. It kind of uses the same thing. And for this assignment, you have to use the deep learning bit to basically feed the system pictures and then tell it what's good and bad. It's pretty easy, but it's a lot of pictures to take. And it has its own built-in light, which is nice. You don't have to use it because it just glares all the time. It gets really hot spots. And then for the PLC, let's see, I can actually probably show you. So we're running Compax Logic, and that just uses, I think, Studio 5000. It's pretty nice. There's a micro logic in here. I don't know why you put it in there. It's harder to use, but I guess you could program it off of there too. And then the HMI, that is in Factory Talk ME. And I like this one because it's bigger and there's more room to play with in the software, so it's easier to design that way. And then everything else is just ins and outs using the PLC software.
What can you tell us about the safety?
All right, so if I designed it, I think it would be a little more safe. But this is the thing. So we have a light curtain here. So I'm going to close this just for kicks. So I have a light curtain and knee stop. So right now it's in a paused mode, paused state. If I hit reset, it resets its little thing, and it keeps going. So if I have an e-stop here, and if I press that, you can see the little red light on the Epson. It shuts everything down and breaks immediately and cuts all power to everything. So I would hit that if something like someone's well-being was at stake. So if someone was in there and accidentally did something, you hit that, and it says e-stop engage. Reset that, safety reset. And as long as everything is closed, you can just hit reset and it's good to go. Well, if the light curtain breaks, it doesn't e-stop the robot. It only comes to a braked halt, like a controlled stop, and then everything else has losses of power, including to the pneumatics. There are a few things that are still online, including the scale and the camera, because they don't really hurt anybody. But everything else goes offline, all power is stopped, and no pneumatics are actuated. So this is more like, this is standard, just to go in there and then move things around and then fill it back up. But this, for the e-stop, that's just in case someone, like something might happen. But to do that, you just make sure the light curtain's not broken. See? You just make sure it's reset, close. And it's ready to go, good to go again.
Are we using safety PLCs?
No, so the safety PLC, that was not fun to use in the PLC3 program. But as for safety, we have 2 safety relays that cross-check each other. And you don't have to mess with those. They're just, they're standard non-computerized things. They just do their job. And then we have 2 safety relays that connect to the motors in there. And it's pretty simple. I like it this way. Programming the safety PLCs is a pain. Yeah, so, yeah.
Good job, Michael.
Thank you.